All right, you guys, we are going to fraction it up. And right here, we're looking at this whole set of fraction comparisons. And at the top, it's like, ready, set, go. Oh man, okay. So let's start in and see what happens. So in the first one, we have 7/11ths, and then we have 8 of the 11ths. Oh my gosh, both of them are 11ths. This one is working in 11ths, and this one's working in 11ths. So if I have 7 of those 11ths, and then 8 of those 11ths, which one is more? Well, the 8 is, because it was 8 of whatever I was working with. These denominators, bottom number denominators, were both the same. So I'm able to just quickly say, well, 8 is bigger than 7, so boom, done. That is awesome. So if I go here, oh my gosh, I'm working in eighths, so all I have to look at are the numerators, because I have 7 of those 8ths and 4 of those 8ths. So 7 is bigger than 4. 4 of those 7ths and 2 of those 7ths, well, 4 is bigger than 2. 1 of those 9ths and 3 of those 9ths, well, 3 is bigger than 1. Okay, if I go here, look at how quick I can do these. When the denominators, the bottom denominators turn out to be the same. I can just look at my numerators. It is so awesome and becomes so quick and nice, right? Okay, all right. Whereas so all these denominators are the same. Now let's notice this set of fraction comparisons. We have, oh man, let's take a look. All right, you go ahead, check it out, and notice anything. And then answer this question, are these just as nice as the ones we just looked at? Go ahead, pause the video, take some noticings, take a little thinking time, write something down, and then start playing the video. All right, here I go. All right, I'm checking it out. And oh man, I'm looking at this one and it's not exactly the same as what I was just doing because the denominators are not the same. But something else is the same, I noticed. I have the top numerators are the same. On every single one of these, the top numerators are the same. So does that mean these are just as nice as the ones I just did? Well, let me think about it. Let me use my fraction sense. So here I have 3 and I'm working with 7ths. So I'm thinking, okay, on a number line from 0 to 1, I'm working with 7ths. So if I break this up into 7 parts, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 parts. Here is 1/7. Okay, right here. That's worth 1/7. Okay. Whereas the other fraction is tenths. So what does a tenth look like? Is a tenth gonna be bigger or smaller than the 7th? Well, when I make my fraction line, I'm not going to be cutting it up into 7. Now I'm going to be cutting it up into 10. And if I cut it up into more pieces, those pieces are going to be smaller. Okay? So now I'm making my lines. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm supposed to try and make them about the same. If you notice, mine got a little bigger there at the end. But either way, my chunk of tenths are smaller than the 7th. The 7ths are bigger. So that is kind of weird in your head because the number 7 is actually smaller than 10. But if we're looking at sevenths, that's right here, a 7th is actually a bigger chunk than tenths. And why does that help me figure this out? Because if I have 3 of those 7ths, well, since 7ths are bigger than tenths, 3/10ths are going to be smaller. So I'm going to go ahead and say 3/7 would be bigger than 3/10 because 7ths are bigger chunks than tenths. So let me think about this next one. 2/5 and 2/8. Okay, well, I have 2 of each. So which of these chunks here, 5ths or 8ths? Which of those are bigger? And in this case, well, if I take my 0 to 1 number line and chop it into 8ths, versus if I take my 0 to 1 number line and I chop it into 5ths, which one's going to be the bigger chunk? The 5ths, because I didn't have to chop it up as much. So 2 of the 5ths is actually going to end up being bigger than 2 of the 8ths. Okay, even though you're like, well, 5 is smaller than 8. But yeah, but when we're talking fractions, we're not talking about just 5. We're talking about 5ths, and we're talking about 8ths. Okay? All right, you go ahead, try number 3. Write this one down, 5/6 and 5/11. Think about it. Think about what we're working with. Think about which are going to be the bigger pieces. And write your answer in 3, 2, 1. Boom! Okay, well, you might be like, okay, the 5s are the same. Yeah, we have 5 of both of what? We have 5/6 here, whereas we have 5/11 here. And if you don't like working the number line, you could also work pizza-ish, right? When I'm working with 6ths, if I'm working 6ths, a 6th is like this big in a pizza. Whereas if I take a pizza and cut it into 11 slices, that's a little tougher to do, okay? 4, 5, 6, 7, 8, 9, 10, 11, okay? My 11th, see how many more pieces I had to make? So this 11th is gonna end up being smaller than the 6th. So I'm going to say that 5 of those 6 is going to end up being more than 5 of the 11s. So are these just as nice? I would say yes, because all I need to check out is that bottom denominator and see which piece is going to be the bigger piece. Awesome! Good luck comparing those fractions.